You know, there's a huge shift happening under the skin of the latest electric cars, and it's on track to solve one of the biggest frustrations for drivers. We're talking about the jump from 400-volt to 800-volt systems, and as you're about to see, this is a total game changer for how we charge and how we drive.
So think about it for a second. When you're on a long road trip, what's the real pain point? For most of us, it isn't really range anxiety anymore. It's charging anxiety. It's that feeling of being stuck at a service station just waiting while your car slowly sips electricity. That's the part of the journey that nobody loves. But what if that wait was just 18 minutes? I mean, really, that's the new gold standard that cars like the Hyundai Ioniq 5 and Kia EV6 are hitting right now. We're talking about going from a nearly empty 10% battery all the way up to 80% in the time it takes you to run in, grab a coffee, and get back to your car. So how on earth is that even possible?
Well, the answer lies in some pretty basic physics. It's a simple but really profound principle that car makers like Porsche, Hyundai, and Audi are leveraging to completely rewrite the rules of the charging game. Let's break it down.
Okay, it all boils down to this one simple formula. The power that gets delivered to your battery, that's measured in kilowatts, is just the voltage multiplied by the current, which is measured in amps. Think of it like a water hose, okay? Voltage is the water pressure, and the current is how wide the hose is. If you want more water to come out faster, that's more power, you can either crank up the pressure or you can get a fatter hose.
So here's where the magic happens. To deliver, let's say, 200 kilowatts of power, a standard 400-volt system has to push a massive 500 amps of current through the cables. But an 800-volt system, to get that exact same power, it only needs half the current, just 250 amps. You double the voltage, you get to cut the current in half. And that one simple change has these enormous knock-on benefits.
See, lowering the current isn't just about one thing. It sets off this incredible cascade of positive effects through the entire car. It makes it more efficient, it makes it lighter, and, of course, a whole lot faster to charge.
This right here, this is the heart of it. All electrical systems have resistance, and that resistance creates wasted heat. The key is that the amount of heat you generate is a function of the current squared. It's called I squared R loss. So when you slash the current in half, you don't just have the waste heat. You reduce it by a factor of 4. And with less heat, the battery stays cooler, which means it can just keep gulping down a massive amount of power for way longer without having to slow down to protect itself.
And the ripple effects are just huge because you're dealing with less current. Car makers can use thinner cables. Thinner cables mean less copper, which means they're lighter and they're cheaper. That reduces the overall weight of the car, which helps with range, and it even allows for more compact, more powerful motors. It is a total win-win-win. Okay, but here's where we need to pump the brakes a little bit. It's reality check time. You'll see car companies advertising these huge peak charging speeds, right? 250, even 350 kilowatts. But honestly, that number can be really misleading. What actually matters for your time spent at the charger is something else entirely.
This comment from an EV owner online just nails it. A giant peak charging speed that only lasts for like 2 minutes before the car slows way down is far less useful than a slightly lower but much more sustained charging speed. That giant peak looks great in an ad, but it doesn't help you on a road trip.
And that brings us to this idea of the charging curve. It's basically just a graph that shows you the charging speed over time as the battery fills up. What you want to see isn't a sharp mountain peak. It's a high, flat plateau. The flatter and higher the curve, the faster you're actually charging.
And here's what that looks like in the real world. When you look at the average charging speed of an 800-volt Kia EV6 compared to a 400-volt Ford Mustang Mach-E, well, the difference is stark. The EV6 maintains nearly double the average speed over that crucial 10 to 80% charging window. That is the 800-volt advantage in action. A flatter, higher curve means more energy gets into your battery faster.
So, does this mean any 800-volt car is going to be faster than any 400-volt car? Well, not so fast. There's one more really critical piece to this puzzle. Charging speed tells you how fast you're adding energy to the battery, but what you really care about is how many miles of range you're adding, and that comes down to efficiency.
And this is absolutely fascinating. An 800-volt car might add more raw energy, more kilowatt hours in 15 minutes, but a super efficient 400-volt car, like a Tesla Model 3, is so slippery and well-designed that it can actually translate its energy into more miles of driving range in that same amount of time. It's a huge reminder that the architecture is only one part of the story. How efficiently the car uses that energy is just as important.
So, with all this info, what's the big takeaway here?
If you're out there shopping for an EV and you actually care about taking it on road trips, here's what you need to focus on.
First, pretty much ignore the flashy peak charging number. Instead, look for the 10 to 80% charge time. Right now, anything between 18 to 22 minutes is the gold standard. Second, remember that a flat curve always beats a high peak. You want sustained speed. And finally, never forget that the overall efficiency of the car, how many miles you get for every kilowatt hour, is the ultimate metric that tells you how far and fast you'll really go.
Man, have we come a long way. Think about it. From early 400-volt cars like the 2011 Nissan Leaf, which peaked at maybe 46 kilowatts, to the 800-volt pioneers like the Porsche Taycan and Hyundai Ioniq 5 that just completely redefined what fast charging even means. And now, these 800-volt systems are becoming the new standard.
And that just leaves us with one final, pretty exciting thought. As 800-volt cars become the new normal, what's next? What's over the horizon? Well, companies like BYD are already testing what they call megawatt flash chargers that are capable of delivering an insane 1,000 kilowatts of power. So yeah, the revolution in EV charging, it's clearly just getting started.